When simplifying a square root, we have to remember that under your radical sign, which is that square root sign, the value in there, the square root of it is, you think to yourself, what times itself is going to give me 16? Every square root has a positive value. So square root of 16 is 4, because 4 times 4 is 16. It also has a negative value. So negative 4, because negative 4 times negative 4 still does give me that positive 16. So down here with the 9s, you can see I have it written, when you see negative root 9, that means I want you to tell me what is the negative root of the square root of 9. So this will be the answer of negative 3. Root 9 says, I want you to tell me what the positive square root of 9 is. The answer to this would be the positive 3. Plus minus root 9 says, I want you to tell me the positive and negative root of 9, and you write it just like that symbol of plus minus 3. When you have a square root of a value and it's not a perfect square, like 9's a perfect square, 16, 25, 36, all of their square roots are whole numbers, or integers I should say, then you have to simplify that square root. So to do that, if we had the square root of 12, that's not a perfect square. I have to look inside there and say, what perfect squares do I see in there? What factors of 12 are possibly perfect squares? So the first one that jumps out to me is root 4, root 3. So I'm breaking it down as root 4 times root 3. If I put it back together, I'm going to go right back to root 12. So here I have the perfect square of 4. So when we look at that, it's going to come out as 2. So what I call these are dead ends. So anytime I can't simplify it anymore, I circle it. Those are my 2 dead ends. So when I take this number and I want to put it back together in its simplified form, square root of 12 is going to be 2, because I dead-ended here, times the square root of 3. I dead-ended there. So another one that you can have would be like the square root of 150. Here, I could do 25 and 6, but say I didn't see that perfect square right away. Maybe I saw 15 and 10. So square root of 15 times the square root of 10 is going to give me the square root of 150. Neither of those are perfect squares. So I need to break it down again to see if there are any perfect squares or if there are any matching squares. So square root of 15 is square root of 5 times the square root of 3. Square root of 10 is the same thing as taking square root of 5 times the square root of 3. Whoops, times the square root of 2. These are what I like to call my dead ends then. So root 5 can't be reduced, root 3 can't be reduced, root 5 can't be reduced, root 2 can't be reduced. So what I'm looking for now is, are there any matching roots? And I see I have 2 root 5s. If I took root 5 and root 5 and multiplied them together, it would give me the square root of 25, which I know is a perfect square. So anytime you have matching roots, when you do this, it's almost like prime factorization of it. When you find a matching root, that means that if I took them and put them back together, it's going to give me a perfect square. So I can square root that. So root 5, that's going to give me the root of 25, which is 5. It's going to spit out as 5. But root 3 dead-ended, there's no perfect square there. And so did root 2. There's no perfect square in there. So now what I have to do is simplify it. I have to put it all back together. 5 stays on the outside. Root 3 times root 2 gives me square root of 6. So 5 root 6 is how to simplify it that way. Sometimes you have a fraction under your radical. When you want to put a radical in simplest form, you cannot have a fraction under your radical. In order for the radical to be in its simplest form, you cannot have that fraction under your radical sign. So to do that, the square root of 15/64 is the same thing as saying I'm going to take the square root of 15 over the square root of 64. You cannot have a radical in your denominator. So luckily, with these 2 problems that we're doing, our denominator is a perfect square. So I'm going to take the square root of 64, and it's going to be 8. Root 15 does not have any perfect squares in it, and when I do the prime factorization, it's just 3 and 5. So that's actually in its simplest form right there. So if you look at the next one, square root of 27/100, same thing as taking square root of 27 over the square root of 100. Luckily, square root of 100 is 10. Square root of 27, though, can be reduced. If you look at it up here, root 27, it gives you root 9 root 3, because 3 times 9 is 27. So that's a dead end, but root 9 can be simplified to 3. So you put it back together, and you're going to have 3 root 3 over 10. Nothing can be reduced. Sometimes we actually have an operation up in our numerator. So the first thing I always do is simplify any roots that I see. Root 8 is the same thing as root 4 times root 2, which is going to give me 2 root 2. So I have 6 plus 2 root 2 over 2. 6 and 2 cannot be combined. 2 root 2 is the same thing as saying 2x, and you would never add 6 plus 2x. You cannot put them together. They're not like terms, just like these are not like terms, these two here. So what I can do, though, is I'm taking 6 plus 2 root 2, and I'm dividing that whole quantity by 2. It's the same thing as saying I'm going to take 6 divided by 2 plus 2 root 2 divided by 2. Now you can see you can simplify these. So 6 over 2 reduces to 3 plus 2 root 2 over 2. The 2's are going to simplify out, so you're going to be left with root 2. So 3 plus root 2 is this in its simplest form.